I want you guys to discuss this with your group really quick. When you guys look at this data right here, now this box plot is the same box plot that we've been working with. Where would you predict there might be outliers? Okay, talk to your group. Go. If you said left, you're right. The data is definitely more spread out there on the left. If you guys see, look, there's not much space going on here. The data is not spread out here. Remember, every single quartile right here has the same number of viewers, data in each of them. Okay, so if there's like 10 data pieces in here, it's way spread out. If there's 10 data pieces in here, it's really condensed. Does that make sense? Yes, it makes sense. So there's a good chance we have outliers out here. Okay, but there's actually a formula. There is a formula that'll tell you specifically if something is an outlier or not. Okay, so here it is. Whoa, what is it? Funny. Okay, here it looks all formalized and stuff. It says an outlier is defined to be any data value that is more than 1.5 times IQR away from the nearest quartile. What? Let's make this more simplified, shall we? Do you guys remember what the IQR was for this? 32. Remember, we took the Q3 and we subtracted Q1. 32. And we got 32, yeah. Okay, so we got 32. That was our IQR. So let's write that down really fast so we can write some notes here. IQR equals 32. Okay, now this right here says that an outlier can't be, well, an outlier is a data point that is 1.5 IQRs away from the quartile. 1.5. It says 1.5, but that's the same as 1.5. Do you guys know what 1 and then 1/2 of 32 is? Well, what's 1 of 32? 32. Just 32. So, and I say and, I'm going to add, what's half of 32? 16. That would equal?
48.
48. Now, that would be the same as if you took 32 and multiplied it by 1.5. You'll get the same result. You'll still get 48. But I like thinking about it like this. Well, it's just 1.5 of the IQR. So 48 spaces away. That's how far a data is allowed to be, a piece of data. So we said that this was 40 right here, or 39. I'm going to say 40 for right now. If I check the distance here, how far away is the data allowed to be before it's called an outlier?
48.
It's allowed to be 48 spaces away. Now, if I go 48 all the way to, what would it be? To -8. -8? Is there a chance we're going to have an outlier for this data? No. Because these numbers represent viewer age. Can you be -8 years old?
No.
So there's no outliers here. And chances are, because this is so small right here, there's not going to be any outliers there. Let's look at an example where there would be outliers. Here we go. Bam. Let's go down, or turn the page. Okay, here's a new set of data. Okay, students at Waldo High School. Man, where is Waldo High School? I'm just joking. Are involved. Yeah, I know. Okay, a special project that involves communicating with people in Kenya. Consider a box plot of ages. Guys, drop the Waldo thing. It's just a Where's Waldo book. Come on. Guys, I'm trying to teach math here. Now I got to teach you about Waldo? Okay, so we have 200 randomly selected people for this data. Okay, can you guys tell me, can you look at this really fast? Just make quick predictions. Tell me what the IQR is. Go. Now, what did you guys predict? What did you estimate the Q1 to be? What would that be about? See, this is about 10 right here, because 10 is halfway. So what would that be? 7? 6? 6? Okay, let's do 6. Okay, what about the upper one? See, this would be about 30 right here. What would this one be about? 32? Can I say 31? Okay, we'll say 32.
Why would you say 31?
You'll see. Okay, so we have 32 and 6. So what is the IQR? IQR equals 32 minus 6, which equals 26. Is that right?
I said it.
Yeah, you're right. Good job. No, actually, this works out better than what I said. Okay, 26 is our IQR. So, hey, students, math students, what is 1.5 of the IQR?
1.5 IQR would
I
be
got
less
you.
than
It's 39.
It'd be 126 plus a half of 26. What's half of 26?
39.
13.
13. So what do we get?
39.
39. So that means data is allowed to be 32 spaces away from the quartile before it's considered an outlier. So let's count the spaces right here and figure out what it is. What would you say this number is right here? Right there.
64.
64. You see, this is 70 right here. Yeah, 64. I'm down with 64. Let's put 64 right here. Okay. What is 32 plus 39? What is 32 plus 39? 60, 40, no, 71. Yeah, 71. So we can go out to 71 and still not have an outlier. Okay, so what is this one approximately?
71. That looks like, yeah.
Because I was saying this was 70 right here.
That looks approximately 71, 72.
Okay, well let's say it's 70. So is 70 an outlier?
Yeah.
No, because we're allowed to go out to 71. Would this one be an outlier?
Yes.
Yes, for sure. We have an outlier here, outlier here, outlier here. All of these are outliers.
71, then it is still.
But normally we wouldn't put the asterisk for something that's not an outlier because that would be a maximum. We should probably extend this line out to here. But we're just estimating right here what these numbers are. So there you have it. That's how you find outliers. You have to find interquartile, an IQR, and a half to find the distance that data is allowed to be from the nearest quartile. So this is the quartile, and this is the quartile. So we can subtract 39 from here, but then we're going to get into negatives, and that doesn't really matter because you can't have negative years.
Why'd you put